Hello everyone, and welcome to today's webinar titled 7 Ways Text Analytics Engines Tame Big Data. My name is Rihanna Collier. I'm Vice President of the Software Division here at SIIA, and I am delighted to have John Falahi and Stephen Toole from Content Analyst here to present and talk to us a little bit about taming big data. We all know that with all the data being produced today, it provides a lot of opportunities for us, but also a lot of challenges as well. So how do we leverage the data and how text analytics engines can help us do that? Before we get started and I turn it over to John and Stephen, I would like to just provide a couple of housekeeping reminders. First, all of your lines are set on mute. We do want to make sure that we answer any questions you have throughout the webinar. Our goal here is to make sure you leave with the information you came looking for. So we encourage you to ask questions throughout the presentation. You can use the chat box to the left of your screen. We will address as many questions we can at the end of the presentation. If for some reason we don't get to your question, we'll be sure to address it offline with you directly. And I should mention that the webinar is being recorded. We will provide the full recording, including the slide presentation, to all the participants at the end of the webinar today. Next, I just want to highlight a couple of upcoming SIA events that may be of interest. We're about to kick off our master class series with our first session on transitioning to SaaS, which is July 9th in Foster City at the IBM Innovation Center. We've got members Dimension Data, Zuora, and Cloud Passage that are going to share some best practices. It's really a great seminar. I encourage you to take a look. There's the link there on your screen if you're interested. I also want to encourage everybody to save the date, mark your calendars for May 20th through 22nd, 2014. SIA is Maximize 2014 event will take place. That's formally our All About the Cloud event, which we've changed the name to focus really on the true theme of the event, which is maximizing the opportunities for ISVs. So it's still everything cloud related, but we're focusing on the opportunities for ISVs in today's market. So mark your calendars. The conference website will launch here in another month or so, and we'll provide updates as it approaches 2014. So with that, I want to go ahead and jump right into today's content and turn it over to John and Stephen. Content Analyst is a member of SIA, and we're delighted to have them here to share their industry best practices and hopefully give you guys some tools that you can walk away with and apply to your business. So with that, John and Stephen, I will turn it over to you.
Thanks very much. Good afternoon, ladies and gentlemen. I'm Stephen Toole, Vice President of Marketing with Content Analyst Company, and with me is John Falahi. Say hello, John.
Hello, John.
So I appreciate everybody joining us today. It's a pretty important topic, and I'm glad this was a topic that resonated with the members. We're actually pretty new to SIIA. We joined earlier this year, but we've been doing text analytics in eDiscovery and the U.S. intelligence community and some other related communities now for about 10 years. You know, it's kind of funny when we think about big data. We've been dealing with big data at a different level in the intelligence communities and the legal communities now for a long time, and so it's pretty appropriate for us to talk to you about some of the things that work really well in managing big data. 7 ways that text analytics engines can help tame it. We look at it as both big data as both a risk and a potential asset. It's a risk and a burden if you don't have good management of it, and it's an asset if you can turn it into valuable insights. And we also look at big data as having sort of 3 parts. There's the structured side, which is your databases, the unstructured, which is divided between audio and video and graphics, and then the other part of unstructured, which is text. And that's really what we're focusing in on today, is the text analytics side. So without further ado, I'm going to ask John to talk a little bit about that concept of the value and the risk of big data. John?
Thanks, Stephen. So as some background before we get into how text analytics can help, we just, as Stephen said, kind of set the stage and the framework for the discussion. For most application vendors, not all, but for a lot, they live on content, either capturing it, managing it, or analyzing it, distributing it, some part of the life cycle, which we'll talk a little bit more in a minute about. But fundamentally, the issue for a lot of our customers is they are collecting data at extreme rates in some departments that they never thought that would collect that much data, like marketing, all the digital marketing assets and information they're collecting. A lot of the work going on because of the infrastructure that we put in place in the last decade. So our customers, the end customer, even us when we're out of work and online shopping, are typing in more information than many companies are distributing on product reviews, comments, etc. And the pipe going around the world, now people at home have a pipe as big as many companies had going to their offices 5 years ago. So we've got some pretty amazing things going on. But that data, if it's not classified and organized, whether it's structured data, and there's still lots of information in structured data that isn't mined properly, it isn't seen from many perspectives, it's seen in the one or two fields that it's targeted in, but it has so many other views that are important, or unstructured data where we really need to tag it and organize it so we know what to do with it as we live on. And one of the key issues for a lot of companies are how do we classify that information and make sure that the classification process is easy to do and maintain. Because if it's not classified and organized, then we can't really leverage it effectively. So a lot of the things that are going on are all about the findability of the information when we need it, and in some cases, knowing that it's not of any value anymore and no longer required, and so we can, quote, delete it or defensibly remove it from the organization's repositories. So if we move on, again, we put together a simple slide to kind of talk people through that information's going through multiple phases, lots of different software out there. I'd love to have listed everybody's product on this list, but we just picked a few samples. But in every one of these phases, information needs to be organized and classified so that the applications that are using it or will use it eventually, whether it's even the storage systems, should know what's going on and have a way to leverage those tags more effectively. So if we really kind of look at that, there's been a lot of approaches over the years that have done that with what I call traditional keyword and rules-based approaches, language-specific, really good, nice taxonomy systems, other types of manual tagging, and other types of approaches. But if the person isn't aware of what other categories exist or new categories come up and they're not available from a drop-down, or if the automatic categorization system doesn't have a rule defined or can't easily create one because the people that build the taxonomy or the data scientists or subject matter experts don't have the time to update it, then those tags are not available in the system, or they might be put in one system like your content management system or records management system, but not in your intranet or out to your repository. So new approaches to look at that information and mine that information are coming around, and that's text analytics. So if we move on to the next slide. I'll just give one piece of background. Prior to joining Content Analyst, I was at a company called Fast Search and Transfer, and we were building systems to help search, organize, and manage information on technology that was, built, in the 90s. Search engines did pretty well, but the one issue was in nearly all types of systems that if the tags, classifications, or way we looked at that information was not predefined and it was a clear relationship like what's a synonym, what's an association, the system couldn't do anything with the data to discover that relationship. One of the things that's a little different now is some of the new text analytics systems like ours can do the mining of that information in a conceptual way. Our product, CAT, and this is the only time we'll really talk about this product except near the end, is one of the new systems and new approaches to doing a conceptual aware understanding of the information. Think of it, quite honestly, as I like to talk about it, as an idiot savant. Yeah, it can look at the information, but once you train it, it understands the language because it all takes everything in as omnicode, so it doesn't care if it's in Japanese or Chinese or whatever language. We can then process it, learn that language, understand how words are used, build a relationship about those, and then actually know that a word or an abbreviation or a code word's being used like another word, and this is why it's been so successful for our friends in the intelligence community, public service sectors, legal markets, patents, and other areas, because the expert doesn't have to know all the relationships or hidden meaning or views like in patents where they purposely obfuscate the terms. The system can learn those and give us a conceptual view, so it's very easy to maintain and update or have the system classify. So this kind of new approach of text analytics, whether it's on structured data or unstructured text, is giving us a new way to allow the system to work like humans. I'll give one last example, which is humans use 5 senses and time to kind of classify everything. So if I say the word coffee, all of us will come up with a different image. I was doing a meeting the other week, and I said the word coffee, and I got a cup of coffee, coffee beans, and then the word Argentina popped up as someone's example. We all have different views, and then if you think a little more, you'll think about relationships. By us mining the text itself, we have a way to build that. And there's a number of different systems out there that you should look at that are doing some conceptual aware text analytics that can augment your systems. So with that as the backdrop, maybe we can look at a couple of different approaches, Stephen. Maybe you can kick off the next one or two.
Sounds great, John. Thanks for the background. So we promised you 7 ways that text analytics helps to tame big data. And as the software companies that you all represent, like the promotional message said for today's webinar, it's your software products that are helping to create the problem of big data, and your customers are going to turn to you, if they aren't already, to say, hey, how can you help us manage this better? Well, the first way that we talk about here is what John mentioned earlier, defensible deletion. So if you kind of think about what we've been doing in eDiscovery and the U.S. intelligence community with our text analytics engine, and that's been used in the court of law in all 50 states, countless times in hundreds and hundreds of cases where judges have accepted this text analytics technology as permissible in culling down from what was, started with millions of documents and emails to just the ones relevant to the case for evidence. It doesn't really get much more defensible than that, and that's where we're going with this. So as your customers say, how do I get rid of this redundant, outdated, and trivial documents, emails, we call them documents, could be content, in a way that's defensible, that's repeatable, that's consistent, that's not subjected to human interpretation, and no one has the time or money or energy to read every single email and document out there to decide whether or not it should be deleted. And you can't just use metadata either, because dates aren't always reliable when it comes time to how relevant is a document. And so that's where the concept-aware categorization comes in, where it reads your documents, your emails, your text, your content, the way a human would, and can understand those concepts, categorize your unstructured data, your customer's unstructured data, use instant context to take known keywords to find conceptually similar terms contained in documents, in emails, etc., to categorically say, okay, these are all conceptually similar and therefore can be defensibly deleted, pretty much beyond the shadow of a doubt. And as John mentioned, it's not dependent on word lookups, dictionaries, thesauri, ontologies, etc. We talk about junk, by the way. not necessarily just referring to spam and stuff like that, because there's plenty of spam filters out there, many of them probably by your companies. But even just a 2-year-old email newsletter from SIIA is a very low probability that that's going to be read again, but it's sitting in your email inbox, sitting in your customers' email inboxes, or emails saying, hey, the birthday lunch is in the conference room, come on down. So concept-aware categorization can identify those types of things and say, these are not necessary and they can be defensively deleted. And then for compliance, it's really a very similar notion, and John's going to talk to you a little bit about that.
Great, thanks, Stephen. So here's kind of the other end of the coin, which is how do we look at the information, and maybe in an early case assessment, or we have a regulatory issue and we want to find all the information. Traditional Boolean search, or some of the things integrated in a lot of the back-end systems, as Stephen said, will have good metadata, might even have a full-text search, but probably don't have a good conceptual aware understanding of information that's in the repository. One of the other things that's a real issue traditionally in a lot of the backups and archives is key information and the way company use terms or the industry uses terms changes over time. So there might be some key reports or key information or things that you need to protect or bring forward in defending a patent or some other issues. And if people don't know the terms that were used 4 or 5 years ago when that report was created by your engineering team, your research team, et cetera, then they probably won't be found. With a conceptual search added to the process, it can mine that information and bring that forward. The other kinds of things that are really interesting is to also understand when you're doing a review and preparing for some kind of regulatory review is to cut your review time, no different that they try to do in the legal community. And there they can talk about hundreds of dollars per hour per lawyer, and all of us know that anyone's time is valuable, and how can we optimize it. And there's a lot of things out there that nearly all of us use to find duplicates, hash-5 approaches, et cetera, that are pretty common. The real interesting part is finding near dupes where you can optimize your review. So if you have content that is similar, for example, drafts, versions, but you didn't know that other people have saved them or backed them up, or they have other versions, and but you're finding them and you want to cut down your review time, so maybe in a couple of paragraphs a few words were changed. Systems would not help you organize those, whereas a smart system that has a near-dupe understanding, a textual near-dupe understanding, which is common in a lot of text analytics engines, will be able to say all these documents are pretty similar. One of the other ends, though, is a conceptual near-dupe. And I don't know how many people are out there like me, but I probably average about 10, 15 presentations a month where I use a similar slide deck, and I might change, I'll be honest with you, the name of the company I'm talking to and reorder the slides, and they're all stored or backed up. And in large companies, financial services, other companies, that's probably going on constantly. And a conceptual near-dupe, a textual near-dupe would say these are not the same, that there are slides that don't match up, so they're not lined up. But conceptually, they're fundamentally the same document. And hence the amount of review time, if you know that these documents are conceptually the same, here's the handful of differences, the couple of words on the first slide were changed in the order, the rest of the slides were changed, or one slide was dropped out, your amount of review time for your internal team can drop dramatically. So some nice ways to find similar and drive down the challenge. And one other key point about this approach that's really interesting is it has the ability to find more like these in a full document, or to use what a lot of search people in Boolean search have always tried to do successfully is document search. Take a whole document and find me other documents like this, conceptually related, not just the keywords that are mined out of the document to build some long Boolean query. And a different approach does a lot of great mining. This has been something that's been highly successful in patent law, where they, as I mentioned earlier, they purposely obfuscate terms or don't use specific terms to try to get the patent to be broader or not be discovered, so that they can keep their patent alive or not find people saying, hey, we've already did something like that, we already have a patent out there. So a couple examples. Stephen, I'll let you do the next one.
Okay. You know, a big challenge with big data is collaboration. How do you share content across functions, across users, across divisions, departments, even across languages? And in terms of, you know, our friends from the content division who we presented to last week, how do you make your content more findable? Or as John was just saying, you know, take a piece of content and say, find more like this. Some of the people on this webinar are from very large corporations, and you know, I can tell you that there's a good chance that there are people in your organizations that are working on similar projects in different divisions, but without the ability to do conceptual search among your content assets. Big data is more of a burden than an asset itself. And so that's what we're talking about here, is doing that concept-aware categorization either among your internal, this is for your customers, of course, among their internal documents and content, or as you produce content for external use, how do you automatically categorize that to make the end consumers of that content more findable, and not just in English, but in any language, and that's another key point. And so being able to automatically apply those categories to your content improves collaboration, sharing, syndication if it's for external use or for revenue. And I know there's a lot of companies on this call that have content designed specifically for revenue generation. If your customers can't find it, it can't generate money for you.
I got one other thing, Stephen, to just highlight on that, that we got some feedback from one of our large analyst firms out there, and they were talking about this capability and how for a lot of analysts, people that sell a lot of their services, information services and research, is they really would love to know when they're working on a document, is anybody else working on a similar document? Or in certain firms that we partner with, they're using the technology to say, is anybody worked on a similar project? Because a lot of times, conceptually, the system can find those relationships even though the exact terms aren't really a match. So someone might be working at one of our favorite integrator firms, and someone's trying to find someone else who's worked on a similar project, and they might look with a regular Boolean search and find a couple of documents, but the 3 or 4 key things or key projects might have been completely missed. And the same thing's true for anybody generating content. Has anybody else generated or working on a similar project? Maybe I can jointly work with them. So there's a lot of ways that collaboration can work even as you're developing the content long before you syndicate it.
Yeah, John, that reminds me actually of another customer that we talked to last week that's producing financial reports. I know there's some companies on the call today representing financial services companies, and they said that they're producing 80-page financial reports and tagging them with between 6 and 10 keywords, and that's it. And you think about all of that rich data and how that could be utilized, leveraged more widely if it was categorized more appropriately. So I'll move on to the next slide, which is has to do with term drift. And John touched on this earlier. You know, you might have a categorization system or a taxonomy system in your product already, giving your customers the ability to help tame big data by categorizing it. But what do you do and how do you help them as new terms evolve? And one of our favorite examples is, Superstorm. Superstorm didn't exist until the unfortunate events of Hurricane Sandy last fall. Didn't exist anywhere, and we all know as software companies and content companies that terms are popping up all the time. Also, thanks to social media, where conversations and dialogues are happening in real time. 3D printers is another example. If you don't have a category for that, how do you maintain that content as new divisions evolve, new product names? All of the ways that new terms evolve and also take on new meaning is another component of this. You think about like spam, for example, took on a very different meaning 20 years ago. It doesn't mean the same thing as it did during World War II. And that's part of term drift too. And so again, getting back to the text-based analytics, concept-aware analytics can understand these concepts in their context and automatically re-tag historical content as new terms. So for example, with Superstorm, let's say you had a bunch of content about really big storms and you wanted to tag those as superstorms. Well, this could actually go back and retroactively re-tag or recategorize old legacy content or data with new terms as they exist and tag new content as it's generated with the new taxonomy. Try and do that manually. It's not a simple thing to do. And so ultimately the results are your content can stay relevant and categorized with new terms as they evolve and change meaning. Okay, and then I'll move on to risk mitigation. As big data, it is a burden. What you don't know can hurt you, in fact. And if you don't know, if your customers don't know what's sitting on their servers, on their networks, in their CMS systems, then there is a liability, there is a burden, not the least of which is increased litigation costs if your customer's company should find itself in a lawsuit. You have basically more content, more big data to weed through to get to the relevant materials germane to a case. And so for all of those reasons, again, concept-aware auto-categorization can help reduce those risks of the big data by giving them the ability to identify, dispose of materials, as well as threading, email threading, which can give your customers the ability to know who knew what, when, and who they forwarded it to internally or externally. So those of you security companies on the line today, your ears might be perking up at the thought of, for security, risk, compliance, having the ability in your products to thread email conversations and set policies related to leakage of information to external domains based on the actual content, not based on metadata or things like that. And by associating terms regardless of spellings and acronyms and those kinds of things, you're giving your customers an incredible ability to enforce security and privacy policies with your products through concept-aware categorization. Okay, John, talk a little bit about trend analysis.
Yep. So one other interesting thing about the technology is we've used a couple of terms, and I should probably go back and qualify them. One is classification and then categorization. And then right now we're going to talk a little bit about clustering, but I'll try to make sure I've got the definitions out. So classification basically says we're going to organize the information, and there's usually two types. Supervised, meaning someone has defined some set of rules or definitions, i.e. a taxonomy or an ontology or some outline of categories, where if the information matches one of those, then it's put into that bucket or, in the modern world, traditionally given that tag. So we've talked mostly about concept-aware categorization. The other option is unsupervised. The system just is told, please organize the information into clusters so that we can at least see what is going on in the information set. So a very interesting approach is how to take information, and even though you might have, for example, an automotive company or a financial services company taken a survey or filled out information that's in the database, but a lot of the text is typed in, short sentences, maybe a little bit longer, about responses to about a product or about a feature or about something. And what you really want to see is what are people talking about in those responses, or looking at Facebook information or other types of things going on in the industry, news trends, news reports, etc. So clustering will take the content and cluster it into groups, create its own taxonomy, so to speak, of here's the information, here's buckets that it falls into. And by looking at that over periods of time or different snapshots of different repositories, you can actually start to see reveal trends and relationships between content that you might not have picked up, or mine some new insights because the system is now showing you here is a large cluster of documents or conversations going on about a topic that we really haven't tracked before, and it will highlight the words and terms for you. So there's a really nice kind of alternative tool to start mining the information, whether it's sitting in your database as the field, as the conversation field, or just streams of unstructured content that you want to take a look at and see what are the things that are popping up in those reports. So another way to look at information completely, quote, unsupervised, to see what is the data trying to tell you, or what is the kind of buckets that are out there. And so that's one piece. And then the next kind of key thing about the analysis, maybe if we go on to the next slide, is language. And we mentioned it up front. One of the key problems I lived with building a search system, and even though we were the only non-English speaking based large search company when I was at FAST, and phenomenal team of linguistics people supporting about 40 or 50 key languages with all the analytics and all the things that we needed in the system. At the end of the day, if there was information in other languages, we couldn't process it. The quality of the mining and understanding of certain languages was less than others. English, German were great. Some other ones kind of fell off, and as we got to the Chinese, Japanese, and Korean, the tokenization was so critical to really understand what was going on in that language set was very difficult. The approach our system takes, not all text analytics systems do it, but there are other interesting approaches in text analytics where it really converts all the language into a mathematical model so that that language can be treated and understood by the system, and then build the concepts. So even though the system doesn't have any predefined dictionaries or any synonym lists, it will actually learn from that language set and work in any language. So we've done a lot of work, again, with our friends in the intelligence community that are looking at every language, and then in the legal community globally, where it's mostly English, but every once in a while French, German, Japanese, other European languages are popping up because those companies have to defend themselves globally or have divisions that are global, and certain reports are in other languages, and those need to be found and reviewed. So kind of one of the new trends for most of us was English was okay 5 years ago. Today the web and digital information is really clearly in the native language, and for large international companies, they need to work in all languages that their employees work in and talk in and write in. And having a system that can help you mine that is really important. And another new trend that is more and more important, people just assume that the systems can do it because they watched the big guys, Google and Bing and a few others, do it on the web all day long, so they just assume that it's pretty straightforward for anybody else to do. And if you're struggling with that problem, you should be looking at some of the new text analytics approaches to help augment what you do to help you out with that. I think that covers that topic.
Cool. So thanks, John. So that wraps up our list of 7 ways that text analytics engines tame big data, reduce the risk and burden, and increase the value or the asset of the big data for your customers. We'll take questions in a minute. Just to recap a little bit about Content Analyst Company. We've been doing advanced analytics now for close to 10 years. As an OEM, we license our text analytics engine to software companies, systems integrators, information services companies to embed into their products and provide that value for their end users. So it's highly effective. In fact, 5 of our partner products were just recently listed in the Gartner Magic Quadrant. And if you subscribe to the 451 group, they just put a report out about us yesterday that you're welcome to take a look at. We're negotiating with them now for distribution rights. And just a few more things. We've got 13 patents on the technology, thousands of end users via our customers, and many of other industry awards and accolades. So I think that's it. John, did you have any other final remarks before we jump into Q&A?
Yeah, the only last thing I'll say is that for all of us, dealing with content and information within our applications and environments for our customers, that, one thing that I've been living with and why I came to Content Analyst is it's all about findability. If someone's looking for information digitally, it means that they don't have it in their head, they don't have it in their fingertips, so they're looking for it. So it's all about findability, and sometimes, a good keyword system and just typing in a handful of words gets you right to what you're looking for. But when you're not clear or not sure what's out there, and you don't know all the terms and words being used, whether the official terms or words or the ones that the bloggers have just created in the last 24 hours, a content-aware approach really solves the problem.
Great. Thanks, John. I see some questions rolling in. I'll turn it back over to our host to moderate the Q&A session.
Thanks, John. Thanks, Stephen. That was great. We do have a few questions. I want to remind the audience that if you do have questions, please go ahead and type them in to the chat box. You also have John and Stephen's emails there on the slides, so I'm sure they're happy to connect with you offline as well. A couple questions I'm seeing are there certain types of information that has to be provided for these types of systems to work?
So for text analytics systems, you need to look at their core technology. All of us are, probably considered natural language processors. Most people, when they think of natural language, they think of systems that are lexiconic-based, meaning they're using word lists and others. But our approach, and there's a couple other new ones out there, machine learning approaches, are content-free, dictionary-free, and learn from the content source. The types of information, nearly all of them are assuming is you're giving us some type of clean text, whether it's XML or just plain text. In most cases, in our system, for example, we actually don't worry about punctuation and lots of other things because we're learning and associating the words. Other systems might need a little of that, but the source is pretty much independent. We would assume, in our case, we don't build an application. I just want to qualify. There are lots of products out there where there is a text extraction tool like Outside In, KeyView, ISIS, et cetera, that will take the content, no matter what forms it's in, and take it from a Word document or a PDF or an Excel spreadsheet or some other form and put it into that kind of generic format. Once we have that, then we're good to go, and nearly any text analytics engine will do the same. So hopefully that answered the question.
So just to clarify too on kind of the language side, and so for you guys, you're saying the engine is language agnostic, so supports all languages.
Yep.
Correct?
Yeah. So that's another great point. So in our case, in some of the newer machine learning cases, we use a core technology called latent semantic indexing, which we own the original patent on. And there's some people also using that technology or variations of it, and then there's some other engines. Those engines, in most cases, are language agnostic, which means they actually take a sample of the information they're going to be working on and learn what the language is or languages. So it could be multiple languages, et cetera. And since there's no dictionaries or anything predefined in the system, it's learning from the text itself, it doesn't really care if it's Japanese, Chinese, Farsi, Russian, English, et cetera. It's going to go then build its own understanding from scratch from the language itself. So hopefully that's one of the things that a lot of the older systems, they're built some phenomenal dictionaries and word lists, and there's some great tools out there that help them in what I call kind of the major languages. But even there, some languages are better than others and how rich they've built the dictionaries and word lists, and someone has to maintain them. And if, as Stephen pointed out, if a new term, whether it's a financial tool or a term used in the news or even inside your company, isn't in those dictionaries or word lists, then that association doesn't exist in the mind of the, quote, system, and that learning doesn't happen. So a new approach from a concept-aware approach would really augment the system.
Great. A couple other questions. How do you keep track of similar clusters or topics across several generated hierarchies over time?
That's a really good question. Hopefully I understand it. Seems to be a couple of parts. So one thing is if you're consistent with your hierarchy, so you've built a taxonomy already, say you've defined it for a records management system. You can take that taxonomy, and we have a tool that we can use to take that structure, and then in our system it's a little bit different. You don't build word lists and rules. You actually give it example documents. So documents you've already organized or have tagged in other systems, you would use as examples or parts of them the key part of that document, because some documents might cover 3 or 4 topics. And the system learns that's what you're looking for. So that's how it learns about that, and it's easy to maintain and add new documents over time to that, so it can update its smarts, or as you decide something new's come along, whether it's inside the company, a new project that needs to be classified, or a new term in the industry. The maintaining is pretty straightforward. We have some tools that allow you to, quote, create those and publish those classification models and actually use them defensively if you're dealing with regulatory compliance or eDiscovery issues. If someone's interested, we can go pretty deep on that in a separate conversation versus here in the webinar.
Great. And this is kind of a follow-up question to that, really, and maybe just something to add. Is there any other specific features that you can talk about from your text classification engine?
Sure. So our system is again, takes example documents and learns from those to build the understanding of the classification. My favorite example is in a previous system and a lot of word-based and rule-based systems, that someone was creating the taxonomy, transportation, automobiles, and then underneath automobiles, passenger cars, trucks, and sports cars. In sports cars, they might say, if you see the word Mustang, add it. But make sure that it says, but if it says Mustang horse, don't add it. If it says Mustang Corporation, don't add it. If it says Mustang airplane or P-51, don't add it. If it says Mustang horsepower, add it. So there's as many, for some categories, as many complex negative rules as positive rules, whereas a conceptual approach would understand all the rules and tag the documents in a related way. The other nice thing is that we have a lot of tools to tell you the precision and recall and other kinds of fun terms that the industry and people in that space would know and make it very interactive. The other parts of the system can do a lot of mining of that information and show you another thing that we do for some of our partners is to highlight, here are alternative words you might look for. So you type in a word and our system will actually show you, you might want to look at these other words. And usually the first, as I call it, handful are variations of the word you put in and are pretty recognizable. And then all of a sudden, words show up and you're like going, I have no clue why this word is on the list. And if you search on that word, you're actually going to start to see that someone's using that word in the same way that the other word you were looking for, or that it's a code word, or a complete misspelling, but when you read the sentence or the document that it's in, you're going, yep, it's the associated word, and we need to understand that.
Mm-hmm. Okay, how do you measure the accuracy of categorization? Are there any specific benchmarks?
Yep, I think the last I knew, we have the highest precision score in a peer-reviewed document. So sitting on our website is an IEEE paper where we took the Reuters set, like most people have, even though it's quite old. And this document's been out for about 4 years. And as last we knew, no one has gotten close to that precision in a peer-reviewed document, which is taking documents, stating what the categories were from a manual, expert review, and then running other systems, and we've scored the highest. And we've been also, as Stephen mentioned, been used extensively in eDiscovery, where the legal review and technical review of our technology has been under probably the most extreme scrutiny and has been accepted in multiple places. And as Stephen said, we're the #1 engine used in eDiscovery tools today.
Now, is the text classification engine able to understand concepts such as the text is about service or contracting?
Yes. So if you, for example, built a category that said, here are services we offer, and put in, say, marketing literature, some write-ups about what you offer, then the system would find all documents that are related to that. So it actually learns from the concepts. And as I mentioned, the other nice thing, if you decide to use it as a search experience versus just a classification experience, you could actually say, find me any other document like this. So my example is the patent and trademark space is one that is quite hot globally. And in a particular example, one of the latest patents that's been out never mentions the word motorcycle, but it completely describes a dual-wheel forked system, motorized system, and goes through a bunch of details, but never uses the word motor or cycle in the entire patent. Other systems completely missed it, and our system just basically, they took their current patent, dropped it in, and it showed up as the #3 document in the list, and no other system even found it. So some different approaches to mining information conceptually.
Great. Now we're approaching the top of the hour. Can you talk a little bit about security?
Yep. One interesting point about our system that in talking to a number of partners and industry analysts, the taxonomy that is out there today for a lot of customers inside of their intranet, for example, is a text-based solution with a lot of these keywords and rules. An interesting thing about that is in nearly all cases, it's pure open text because it can't be encrypted, or the performance of the tagging process dramatically slows down. And so you're sitting with actually a giant security hole if anybody has access, can get outside access to that. Because if you think about most of the taxonomies built for companies, it is a complete description of the company. The hierarchy, the structure, key projects, product names, code names, financial records, if they happen to tackle the one that's maybe the records management taxonomy, excuse me, I'll get the word right eventually. Whereas with our system, we actually own patents where the categorization engine that we build when we're done with the examples is a complete mathematical model. So I can't say that it's encrypted, but I can say it's cyber secure. And then the other nice thing is, we didn't mention, we're an in-memory engine. That's why we weren't very popular before, 5 or 6 years ago. We were kind of costly. Today we're kind of like in demand. In-memory is in demand. So we're an order or two magnitude faster than any other approach also, because once we convert it into this mathematical model, to convert documents on the fly into it, tag them, given our vector model, is very quick. So the two things: one, there's no way to crack it open or figure out what's going on, because all you're going to get is this kind of complicated vector map, which is just a mathematical model. And two, because it's that, we can put it into memory and get extreme performance for classifying and tagging documents.
Great. We've got about 7 or 8 minutes left. Let me throw one more audience question at you. Outside of documents and emails, is there applications for this technology against database information systems, and how would that work?
Yeah, so this is a personal hot button for me. There's no such thing in my world as unstructured data. If there's text, there's some structure. Whether it's a Word document or even a tweet, there is something about it that has a container, and we mine it. You go all the way to what people consider structured data, and structured data is really, to me, a database is fundamentally saying, I have organized some predefined metadata fields so I can optimize the organization and bucketing of information. But 9 times out of 10, there's more text in that particular bucket, even if it's a person's name, to turn it into an entity so that we can recognize it in other text or other parts of that database record is critical. So can we work with database information? Absolutely. Is it another way to kind of organize and look at it and see what else is associated? So an example, I'll take it one step. How could we take in database records and also find out there are other documents in the system that are related to this customer or this partner, or coming from our call center information set? And we want to understand, is there something going on or a trend between what we have in our system as revenue and what are we getting in our other systems? So some interesting mining of how we can take structured data and unstructured data in the world of most people and find the relationships and overlaps or commonality.
Great. I think we have time for one more. So I've got one more audience question here. Is the text classification engine able to understand global information such as the identity of the sender or the topic of the text in order to make a more accurate prediction?
Yep. We do that, for example, inside of parts of our system for email threading, where we really want to understand, can we thread on who the author, who the sender, the topic, source topic, et cetera. So extra metadata passed to us enhances the way we work. So an example, I'll use a different example than legal. I'll talk about our friends in the Beltway. They already know who all the known bad guys are. They want to understand who the bad guys are talking to that they don't know. So they want to use entity extractors and mark up names so that John Falahi is treated as an entity and Stephen Toole is treated as an entity, and so pick your favorite names. And then C, who are they related to as other entity types, or where are the relationships between these people and other documents or other conversations, and who's in that conversation. So we can show some different techniques to help people mine that. You've got to do a little bit of work in another system prior to us, but once we have that metadata, we can leverage it.
That's great. Thank you. We are at the top of the hour, so I want to thank both John and Stephen for their time today and for the valuable information, and remind that the attendees that the recording and the slides will be made available to you shortly. You will receive an email with the information to access those. So with that, I want to conclude today's webinar. Again, thank you, John. Thank you, Stephen, and I wish everybody a great day and the rest of their week.
Thanks so much, and if anybody has any follow-on questions, our email addresses are both on your screen right now. We'd be glad to take any other questions or engage in further discussions with anybody on the call today. Thanks a lot. Really appreciate it.
Thank you.
Thank you.